So welcome everybody to this latest A2 video on 162 Maths, and in this continued video on series and sequences we're focusing on geometric progressions with finding and using the sum of n terms in a GP. Now, just like with arithmetic progressions, we can also derive a formula that allows us to quickly find the sum of n terms in a GP. Now, to do this, let's start by actually writing down what the sum of a GP is actually going to be of n terms. So the sum of n terms in a geometric progression is, and that's going to be Sn equals a plus ar plus ar squared, and that's going to go all the way to our nth term, which can be symbolized as ar to the n minus 1. Now from this, if we then multiply both sides by r, then what happens is I'm going to end up with r times Sn equals, my first term times r by r is going to be ar. The second term multiplied by r is going to be ar squared. The third term is going to be ar cubed, and that's going to go all the way to my last term, which ar to the power of n minus 1 times r is just simply going to be ar to the power of n. Now from this, if I then, and let's just move the screen a little bit up, that if I then subtract the two lines, so let's just call this hashtag 2 and hashtag 1. So if I subtract 2 with our first line, then what happens? Well, I'm going to end up with rsn minus Sn, because I'm taking these two lines away from each other. So I'm going to do this line here subtracted by this here, and then the right hand side, what's going to happen is going to end up that things are going to cancel. So this ar is going to cancel with that ar squared is going to cancel with ar squared, ar cubed will cancel with that, and obviously the previous term then would answer, so that would be plus ar to the n minus 1. So those two things would cancel. So the only thing that I would have left would be the subtraction of those two things there. So it would be ar to the n minus a. Now from this, what we can then do is factorize both sides. So common factor on the left hand side is going to be Sn, so that's going to be Sn, and that's going to be r minus 1, equals, and a common factor on the right hand side is a, so if I factorize with regards to a, end up with Rn minus 1. And then from this, what I can then do is make Sn the subject, and I do that by taking that left hand bracket over to the other side. So what I end up with is Sn equals ar to the power of n minus 1 over r minus 1, and there I have kind of generated and derived the formula for the sum of n terms. So then what we've generalized then is the sum of n terms in a GP can be given as one of these two formulas. Now it doesn't really matter which one you tend to use, it's all about personal preference, but as long as you are using them correctly, then that's all that matters. Now again, just like with arithmetic progression, the sum of n terms formula, this is going to be given to you in the formula book if you are given one on your syllabus. So it's not a case of remembering these formulas, but it's really important that you're able to know how to use it, and also recognize that there are two. So in this first example, we've got 1 minus r to the n with 1 minus r as the denominator, and in the second version we've got rn minus 1 in our top numerator and r minus 1 at the bottom, where a is going to be our first term, r is a common ratio, and n is the position of the biggest term. Let's have a look at going through some examples. So in this first question, it's asking me to find the sum of the first 10 terms of this geometric series. Now obviously with this, what I can do is I can carry on the sequence till I've got 10 numbers in the sequence and then simply add them up, but a much easier way would be to find the variables in the formula to give me this sort of answer. So for this, it's always good practice for you to write down which formula you're actually using. So I'm going to go for a, and then 1 minus rn over 1 minus r. Now to use this formula, I need to pick out the key bits of information. So from the question, I can see that n equals 10, and that a is going to be equal 5. And to work out r, all I've got to do is just to divide two consecutive numbers together. So I'm going to go for 15 divided by 5, which gives me 3. So therefore r equals 3. And again, it's got to make sure that you are, if you are doing this, that you are doing two consecutive terms, so that the a's cancel and then you're left with the correct r. So using these three numbers, what I'm then going to do is substitute the values into the formula to give me my answer. So here I've got S of 10 is going to equal 5 times 1 minus 3 to the power of 10 over 1 minus 3. Now again, that's going to give me a few negatives, but will give me a negative on the bottom and a negative at the top, which therefore gives me a positive answer. So here if I just simply type it into my calculator, so I've got 5 times 1 minus 3 to the power of 10 over 1 minus 3, and that gives me an answer of 147,620, and there is my final answer. So looking at question 2, so it says find the sum again of the first 10 terms of the geometric series. So this is giving me a second one. So again, I'm just going to go through the notions of working out what all the components are going to be. So here A is going to equal 40, N is going to equal 10 from there, and then to work out what the R is going to be, I'm just going to take AR divided by A. So the second term is 20, the first term is 40, giving me an R value of a half. So from this, substituting numbers in, I've got that S of 10 equals, and I've got A, which is 40, times 1 minus, and it's going to be 0.5 to the power of 10, and over 1 minus R, which is a half. And again, if I simply type that into my calculator exactly in that form, so I've got 40 times 1 minus 0.5 to the power of 10. Again, if you want to use a half, like 1 over 2 instead of 0.5, that's absolutely fine. It should give you correct answers. Always find when using a calculator, sometimes that decimal, using the decimal version does prove handy. So from this, I get that the sum of the first 10 terms is going to be 79.921875. There is my final answer. So looking at example 3, it says that the first term of a GP is 8 and its common ratio is R. And the first part is asking us to write down the second and the third term of the series in terms of R. So from this, let's just write A. That if the first term is, well, recognising algebraically what the first three terms are, well, I know that A equals 8, because it tells me in part of the question. So then if A equals 8, what's that going to be? It's going to be 8, and then 8R, and then 8R squared. And there's the first three terms. Now for B, it says given that the sum of the first three terms is 38, so that basically means that S of 3 equals 38. Find the two possible values of R. So for B, what I need to do is add up these first three terms. So it's going to be 8 plus 8R plus 8R squared, and that's going to be equal to 38. Now the reason why I've not used the sum of n terms is simply because I'm only working out what the first three terms are, and it's obviously going to be connected to the first part of the question. So from this, I can then notice that it resembles a quadratic, so let's just write this as 8R squared plus 8R plus 8 equals 38. Take the 38 over to the other side, so I've got 8R squared plus 8R minus 30 equals 0, or 4R squared plus 4 minus 15 equals 0. Now from this, what I then need to do is solve this for R, in which I can either use my calculator or I can use factorising, whichever floats your boat. So I get 8R, I think it's going to be plus, or it's going to be minus 3. And 2R plus 5. And there should be an R missing there, so let's put that there. And then from this all equals 0. So solving this, I get R equals 3 over 2 or minus 5 over 2. And there are my two values of R. Now moving on to example 4. Let's just move that up a little bit so we've got a bit of space. So the question says that a geometric series has a common ratio of 3. If the sum of the first 5 terms is 605, find the first term. So in terms of the information I've been given, I know that R equals 3. I know that the sum of 5 terms is 605, and I need to work out what A is. So then using this bit of information, we know that S of 5 is going to be equal to A 1 minus R to the 5 over 1 minus R. And that's all equal to 605. Now if I substitute R is 3, so let's just write that down. So I get a of 1 minus 3 to the power of 5 over 1 minus 3 all equals 605. Now if I take this over to the side, so what I end up with is a 1 minus 3 to the power of 5, and that's going to equal to 605 times minus 2. So from this I get that a to 1 minus of 3 over 5, 3 to the power of 5 I should say, is going to be equal to 605 multiplied by minus 2, which equals minus 210. Then obviously I can then work out a by taking that to the other side, so I end up with a equals minus 210 over 1 minus 3 to the power of 5, and if I just put that into my calculator, I'll get an answer of 5, and there is my value of a. Now moving on to example 4, let's just move up a little bit so we've got a bit of space. So the question says that a geometric series has a common ratio of 3. If the sum of the first 5 terms is 605, find the first term. So in terms of the information I've been given, I know that r equals 3. I know that the sum of 5 terms is 605, and I need to work out what a is. So then using this bit of information, we know that s of 5 is going to be equal to a 1 minus r to the 5 over 1 minus r, and that's all equal to 605. Now if I substitute r is 3, so let's just write that down. So I get a of 1 minus 3 to the power of 5 over 1 minus 3 all equals 605. Now if I take this over to the side, so what I end up with is a 1 minus 3 to the power of 5, and that's going to equal to 605 times minus 2. So from this I get that a to 1 minus of 3 over 5, 3 to the power of 5 I should say, is going to be equal to 605 multiplied by minus 2, which equals minus 210. Then obviously I can then work out a by taking that to the other side, so I end up with a equals minus 210 over 1 minus 3 to the power of 5, and if I just put that into my calculator, I'll get an answer of 5, and there is my value of a. So in this example 5 it says find the sum of the geometric series, and it's 20, 10, 5, and it goes all the way up to 5 over 16. So from this bit of information we know that a equals 20, r is going to equal a half. Now here to find the sum I need to know what n is, and I don't know what n is, so that's a bit of a question mark. I do know that the last term is in which n is going to equal 5 over 16. So the first thing I need to do is find n. So to find out what position is this. Now I could keep going on to find that out manually, which would be absolutely fine, but let's see if we can how we work this out algebraically. So first things first, we know that in terms of the nth term, so we've got a times r to the n minus 1. Now use this to find the value of a, r, or n is going to equal 5 over 16. Now I know that a equals 20. I know that r equals 0.5 to the power of n minus 1, and n is what I'm after. So from this, let's just do a bit of rearranging. So let's take the 20 over to the other side. So what I end up is with 0.5 n minus 1, and that's going to simplify to give me 1 over 64. Now you can notice here that I've got a bit of an equation thing going on, but my unknown is a power. So how do I do that? Well, I do that by using logs. So if I take the log of both sides, then what I end up is with log of 0.5 to the power of n minus 1 over to the log of 1 over 64. Then obviously I take the n minus 1 over to the other side, and so what I end up with is still log 5, well not to the other side, to the front I should say, of 1 over 64. And then I'm going to take the log of 5 over to the other side, so I end up with n minus 1 equals log of 1 over 64 divided by log of a half, or 0.5, whichever floats your boat. So then from this, n is just going to equal that plus 1. So if I then type all of this into my calculator, I get an n value of 7. So then to work out the sum of s of 7, or the sum of 7 terms, I'm going to use a, which is 20, and then 1 minus r, which is 0.5 to the power of 7, all over 1 minus 0.5. And if I quickly type that into my calculator, so I get 21 minus 0.5 to the power of 7 and 1 minus 0.5. It gives me a final answer of that the sum is going to equal either 635 over 16, or if I want to write it as a decimal, that would be 39.6875. But either of those two ways would be absolutely fine. So now let's have a look at our next example. So the next example says that a common ratio of a GP is -5 and the sum of the first 7 terms of the progression is 449, and the question's asked us to find the sum of the first 3 terms. So let's have a look at the information we've been given. So from this we know that the common ratio is -5, so r equals -5. We know that the sum of the first 7 terms is 449, and what we've been asked to find is the sum of the first 3 terms. Now clearly what is missing here is I'm missing an a value, so what I need to do first is find a. So in terms of using the little bit of information that I know, which is this, so using S7 equals 449, so then that means that S7, and again from this, let me just quickly write down the formula. So a 1 minus r to the 7 over 1 minus r is going to equal 449. So substituting those numbers in, we end up with a 1 minus, now r is -5, which I'm just going to put in brackets, to the power of 7 over 1 minus, and it's going to be -5 there, and that all equals 449. So in terms of simplifying this, I get a 1 minus and then -5 to the power of 7 equals, and it's going to be 449 multiplied by 6. So simplifying that, I get that a equals whatever 449 is times 6, all divided by 1 minus -5 to the power of 7. And again, if I just simply type that in, it looks a bit of a mess. And again, you can feel free to simplify any of that. So I get 1 minus -5 power 7, and that equals 1 over 29. So now we know that a equals 1 over 29, so let's just stick that information here. So a equals 1 over 29, so that means then that the sum of the first 3 terms, so when n equals 3, we're going to have s of 3 is going to equal a, which is 1 over 29, 1 minus r, which is -5 to the power of 3, all over 1 minus r, which is -5. And again, just be careful in terms of how you're entering this on your calculator. So you'll have fractions over fractions, but hopefully you can practice and do this with me. Now when r is a negative number, I strongly recommend you do put it in brackets, and then just spot the fact that when you've got negatives in there, and we should have an answer of 21 over 29, and there is the sum of the first 3 terms for this particular GP.